In this problem, we're taking a copper coin and we're heating it. And then we drop it in some room temperature water. We're told that there's 32 milliliters of the water. And because of the coin, the temperature of the water rises 2 degrees to 24 degrees Celsius. And so the question is, how much heat was released by the coin? In this universe, you only have two components. You have the copper coin, which is the system, and then you have the water, which represents the surroundings. In order to obey the law of conservation of energy, energy must be conserved. Any change in energy in the system must have a corresponding change in the surroundings. In this case, the heat lost by the copper coin is equal to the heat gained by the water. Let's replace Q with MC delta T. M stands for mass, C stands for specific heat, and delta T stands for the change in temperature. We're told the volume of the water is 32 milliliters. And because the density of water is 1 gram per 1 milliliter, the mass of this water is 32 grams. It's not exactly 32 grams because the density fluctuates with temperature, but it's close enough at room temperature. The specific heat of liquid water is 4.184 joules per gram degree Celsius. The final temperature of the water is 24 degrees, and the initial temperature of the water is 22 degrees. So the change in temperature is 2 degrees Celsius. So the heat absorbed by the water is 268 joules. And because the only other thing that exists in this universe is the copper coin, that heat that the water gained must have come from the copper. So we can say that the copper lost 268 joules.